1, 2, 3. Hey physics students, it's Haley and Odette.
Today's video is about plane mirrors.
Before we do anything, we need to review the law of reflection.
Woo!
Woo indeed. What we learned was that if you had an incident beam, like this one here, in order to find the reflected beam, you had to draw on your normal line and then draw on your reflected beam. Okay? So really quickly, to review, what we would do was we'd say, all right, well, here's my protractor. You'd kind of rotate it around to put it so that it was parallel with your boundary, or lined up with your boundary. You'd make a mark out here at 90 degrees, and then you would use your ruler. Oh, undo, sorry. You would use your ruler and draw in a dotted line like that to represent your normal line. Okay, so let's label that normal line. And then what would happen is you would take your protractor and you would measure your angle of incidence. So in this case here, it looks like my angle of incidence is, get this guy in place. So it looks like my angle of incidence, this angle here, is about 10, 20, 30, 40, 50, it's not quite up to 60, so let's call it 59 degrees. So that's my angle of incidence. Okay? So what that means then is my angle of refraction also needs to be 59 degrees. So if I spin this guy all the way around, and I make a mark over here at 10, 20, 30, 40, 59 degrees, then I can put in my reflected beam. 59 degrees, just like that. Okay? And so then what I know is, I know that now my angle of reflection is also 59 degrees. Okay? So that's sort of the technical way to make that drawing. But it turns out that really, if your goal is just to put in your reflected beam, if your goal is just to draw this, then there's a way easier way to do it. Specifically, you could do it without drawing your normal line. Because if this angle here is 59 degrees, that means that this angle is 90 minus 59 degrees, or 31 degrees. Which, by the same process, means that this angle here is also 31 degrees. So again, if our goal is just to draw on that reflected beam, there's a way easier way to do this. So let's try that. Another way to do this would be this. Take your protractor, line it up with your point of contact, spin it around so that it lines up with your boundary. Make sure everybody's all lined up and happy. There we go. Oops. Okay, and then what you can do is kind of cheat and go, all right, well, let's see. There's not really a name for this, so I'm going to call this angle here my cheater angle of incidence. All right, so that angle is 10, 20, 31 degrees. Well, that means that my angle on the other side also has to be 31 degrees. So 10, 20, 31 degrees. And then draw on your angle of reflection, or draw on your reflected beam, rather. 31 degrees. All right? And what we're left with then is a drawing that is a little bit less complicated, and it's got both my incident angle and my reflected beam. All right? What I've just done here does not have a technical name. I'm going to call this the cheater method. All right? Because I've drawn in my reflected beam without actually measuring my angle of incidence. Okay? I measured this angle here. It was 31 degrees, and then I said, okay, well, this has to be 31 degrees also. But I haven't actually measured my technical angle of incidence. All right? So what we're going to do now is we're going to use that same idea to find this dude's reflection. Okay? So here's what we're going to do. We are going to figure out where the image of different points on our dude is. In other words, suppose I want to find out where in the mirror the image of his hand is. Okay? So what I'm going to do is I'm going to draw beams of light that go from his hand to the mirror. So I'm going to do all of these ones in red first. All right, so here's my beam of light. It goes from his hand to the mirror. There's nothing magic about this line that I just drew. All I did is I drew a line that went from his hand to the mirror. Okay, and what I'm going to do now, what I'm going to do now is I'm going to use my protractor and kind of repeat that process I just used a second ago to draw in my reflection. All right, so using my cheater method, my angle of incidence is about 10, 20, 30, 51 degrees. Again, that's not technically my angle of incidence, it's the cheater angle of incidence. But I know that my angle on the other side needs to be the same thing. So if this is 51 degrees, then I want to go 10, 20, 30, 40, 51 degrees. And I can put in my reflected beam. Now, what we didn't do yesterday, or in the last video rather, is put in an extension of that beam. Okay? So often what happens is your image is formed not by the actual light that reflects, but where your eye thinks that light is coming from. So what you can do is use your ruler to make an extension of this reflected beam. Okay, notice I'm just extending the reflected beam. Okay? So that's that. So our image is going to be somewhere on either the reflected beam or the extension of the reflected beam. And to figure out exactly where it is, we're going to repeat this process. So what I'm going to do now is I'm going to make a new beam. So here we go. Oh, I wish that had been red. Let's try that again. All right, make another beam. Okay, and I'm going to repeat the exact same process that I just did. I'm going to use my protractor and find my reflection. Unfortunately, I am off of the screen, so how can I fix this? Okay, there we go. I just made a little more room there. All right, so once again, my kind of cheater angle of incidence is 10, 20, 30, 40, 50, 60, 71 degrees. So I'm going to put in my cheater angle of reflection at 71 degrees. So unfortunately, the top of my protractor is off the screen, but imagine starting at the top and counting 0, 10, 20, 30, 40, 50, 60, 71 degrees. All right, so now I can draw in my reflected beam, like that. You're always going to make an extension of that reflected beam going back the other way. So it looks something like that. I'm not using a ruler here, so this is not perfect, but it should be something like that. Okay, and you'll notice those points, those lines cross right here, right? Okay, so let's repeat that process now for one last beam. Okay, so here we go. I don't know, let's do one that goes, I did it again. Let's do one that goes like this. Hits the mirror. Bring down the protractor. Let's clean up the stuff from before. All right, so it looks now like for my new angle, I want to measure this angle here. So 10, 20, 30, 40, 50, 68 degrees, it looks like maybe. So that means that my reflection needs to be at 68 degrees. So 10, 20, 30, 40, 50, 68 degrees is right about there. Put in your reflected beam, 68 degrees. Use a dotted line to create an extension of that. Oh, I wish this had been red. There we go. Use a dotted line to put in an extension. And lo and behold, I've never said lo and behold before. I wish I hadn't just said that. It crosses once again at this point. So what that point represents is, oops, I erased this guy's arm over here. What this point here represents is where the dude's hand is. So look, here's the object hand, all right? And then over here is the image of his hand. All right? So let's repeat that process. Okay, I'm going to change colors so that my drawing doesn't get crazy cluttered. So I'm going to repeat that exact same process for his hand, for his other hand. So we'll call this object hand 1 and hand 1. All right, so over here we're going to do, here's his other hand. Okay, so what I'm going to do is I'm going to draw beams of light leaving his hand and hitting the mirror. I'm going to repeat the exact same process. What I'm going to do this time, though, is I'm going to cheat for one of them. I keep saying cheating. So I'm going to do my lines in green now. So let's pick a nice green. There we go. All right. It turns out that if you imagine a beam of light going, I wanted that to be solid. If you imagine a beam of light going straight from his hand into the mirror, like literally parallel to the ground, perpendicular to the mirror, that beam of light is going to reflect. Get this out of the way. So that green beam of light that I just drew there is going to go straight in, and its reflection is going to go straight back the way it came from. So then your extension is just going to be a nice dotted line that goes this way. All right? So the reflection of his hand should be on that straight line. If you go back and look at the red one that I drew before, same thing works. Look. Let's go back to red for a second. If I draw a line that goes straight in, its reflection is going to go straight back, and the extension goes, whoa, shoot. The extension goes straight through that point again, right? Okay, so there's one of my beams. I know that my reflection is going to be somewhere on that dotted line. All right, so let's repeat the process. Let's pick another beam. Maybe it hits up there. So we need to use our protractor and measure some angles here. So let's see, once again, my cheater angle is, I'm trying to measure this angle here, so 10, 20, 30, 40, 50, 68 degrees maybe. Which means that my reflection also has to be at 68 degrees. So 10, 20, 30, 40, 50, 68 degrees. Put a mark right there. Grab the green pen. .68 degrees we said was right there. Don't forget to extend it with the dotted line. Cross is way out there somewhere. Okay, let's repeat the process for one more green line. Let's move our protractor out of the way again. We're going to do one last green line. That's going to hit right there. Grab the protractor to find our reflection again. So our cheater angle there is about 76 degrees. Right? 10, 20, 30, 40, 50, 60, 76. So I got to come up here to 76 on the other side. Put in the reflection. 76 degrees. Don't forget your extension. And once again, it crosses right over at that other point. So this point here is the reflection of the dude's hand. So what I'm going to end up with is an image where my guy has one hand up in the air and one hand down here. So it's going to look something like, and then his other arm goes down, which means that his head must be in here, and his legs, and you'll notice the image is backwards, right? Just like ambulance on the front of an ambulance, right? Okay, so that is how you find your the image in a mirror. The big thing I want to point out, because this, despite the fact that it's tedious, once you figure out how to do this, it's actually not that hard. Please notice that every time I did this, the dotted lines represent extensions of the reflected beam. Okay, so looking at this beam on the top, it leaves his hand, hits the mirror, reflects away from the mirror, and it's that line there that I extended. Okay, so you just extend the reflected beams only. All right, there you go. Happy ray diagrams.